Hey, what's up, guys? Welcome to my YouTube channel. And in this a series of maybe 2 or 3 videos that I will introduce the cyclotomic, cyclotomic, or hopefully pronunciation correct, cyclotomic polynomial. And this video I will basically prove that one application. So, or maybe in this video let's just talk about the definition and some basic property of cyclotomic polynomial, because this actually can be very deep. Okay. Hope you guys subscribe to my channel, and this video should be like 3 or 4 list. And I will put it into my analytic number theory. So if you are interested, then you can check out my video list. Okay. Okay, so let's write down the definition. So let's consider, so n is a integer greater or equal to 1. So let's define phi n of x to be like, you consider all the GCD, all the number which is corresponding to n, and 1 from 1 to n, j from 1 to n, and x minus exponential 2 pi I j divided by n. Okay, so one definition. And let's directly do some example. So phi 1 of x is very simple, right? Because like x is like x minus 1, right? Because the only roots of one root of unity is 1, and corresponding to 1. And then for phi 2 of x, that you're x plus 1. Because what? Because if now it's n is 2, right? So if n is 2, right? So if your j is, you can only like put j equals to 1, you cannot put j equals to 2, because 2 and 2 has the greatest common divisor 2. Okay, so you don't care about this. Basically, this is the same as x squared minus 1 divided by x minus 1. Okay, and then phi 3 of x, whereas you can consider the 3-root unity omega and its square. So basically it's x minus omega and x minus omega square, where omega is half plus square root of 3i. So this is x squared plus x plus 1. And the phi 4 of x will be x minus I and plus I. Because the only 4-root unity is like plus or minus 1 and plus or minus I. But this plus or minus 1 is already this will not correspond to 4. So this will be x squared plus 1. And the 5 of x is like only 5 is prime. So you only delete the 1. Then so you get x4 plus x cubed plus x squared x plus 1. Okay. So this is the one definition of the cyclotomic polynomial. So it's basically from your definition, you can just directly reproduce the results. Okay, so there's a fact that there's a 2 fact that I will not prove here. I will prove one of it. The first one is that this phi of n of x is irreducible. Actually, this proof is non-trivial, so I will prove in the next video. And the all the degree of not degree, the coefficient of this is integers. Actually, one can prove is plus or minus 1 is more difficult. Okay, so these are facts that I prove in the next. Okay. Okay, so let's do something interesting. Okay, so property. X minus 1 is d divided n 5d of x. Okay, and the second one that for n greater or equal to 2, our phi of n of x is reciprocal. So basically it means that there's this, you get phi of n 1 over x is x phi of n. So it's sorry for the same name. And the phi of n of x is phi of n is the Euler number, or the Euler function. Or this is called Euler torsion torsion function. Yeah, torsion. I forget how to spell it. Torsion. Yeah. Okay, so basically this 5n defined to be the number of the, you consider all integer less than equal to n equal to 1, and the GCD of Gn is 1. Basically, it's all the integer less than n, and which is co-prime to n. Yeah, so it's Euler torsion function. Yeah, okay. So 510 is 4. Because 510 contains like 1, 3, 7, 9. Okay, so what we have is this. Oh, so these two not difficult. So let's go to oh, also third one. So third one is also important, and basically it says what I'm gonna prove here is very simple. So 5x has integer coefficient. Basically, it belongs to this integer of x. And the plus or minus 1 I prove in a future video because it's like much more tricky. Okay, so first one, very simple. We just write xn minus 1, just give you this. 1 minus exponential 2 pi I j divided by n. Okay, so you can consider any possibilities of j and n. Okay, so you can just let jn to be d, and then you can define j prime n prime will be 1, j prime divided to be j divided by d, and then n prime defined to be n divided by d. Okay, so your xn minus 1 can be directly reduced, right? Reduced to all the possible d. Okay, so you can write it as this. Basically it's the same. You consider all the d possible d, right? And d belongs to n, and for that d, you consider all the j prime which is co-prime to that d. Okay, but by definition, this is just phi of d of x. Okay. Okay. So now let's prove the number 2. So we prove this. Now we prove this. Okay. Second one is a little bit tedious, but I still want to do. So idea is that by induction. So we know that phi 2 of x is x plus 1. So phi 2 of 1 over x will be 1 over x plus 1 is 1 over x 1 plus x. So it's 1 over x phi 2. So this is a base case. So now we suppose that for like suppose this reciprocal 1 is true for n less than m. So let's consider m. So x m minus 1 is d m n 5 d of x, and so 1 of x m minus 1 is equals to d divides m, and 5d okay, 5d 1 over x, and okay, then we can use our conjecture, our mathematical induction. So this term, right, is basically can be written as this, can be written as one from d less than m, and d divides m, and 5d 1 over x times phi of m 1 over x 1 over x minus 1. Okay, so this is just directly write the results. Okay, now we use the, okay, so now let's times the equation, and times both sides using x m equals to d divides m x phi to a d. Okay, so this is another result. Basically, if you do the Euler torsion function, and the d divides n is become n. So this proves that you can check out my analytic number theory, but this one is, I think it's not difficult. You just write down definition. Almost the same thing as previous proof. So you times this, you get 1 minus x to the m equal to some big term. Okay, here this term. Let's just write down. So we got 1 dm phi of d, 1 over x phi to a d, and phi of m 1 over x minus 1. Okay, so now this that one can use our induction results, right? So we refer to induction. So this term is basically phi of d x. Okay, the 1 dm and the d divides m, and the phi of m 1 over x minus 1. Okay, then prove the results. But basically, you just flip all the rest to the left-hand side. Okay, and combine. Basically, you prove the results because now xm minus 1 is the same thing combined with the 1m term. So which finish the proof. Oh, by the way, sorry, I forgot because I times this, right? So there should be x phi of m term here. So x phi of m term. Okay, so yeah, that's it. So once you have this, then you get this and this times this. Okay, and then you just do using the definition of this. Absorb, you can see these terms will factorize into this term and the phi m. So these terms must be phi m. Prove the results. Okay, now we prove the third. Basically, this phi n x is like has the integer coefficient. Okay, and y. So it's also proof. So number 3 is proof by induction. Also by induction. So we can suppose n less than m, phi of n, x belongs to z of x. Okay, so since it's true, so this means that we can write xm minus 1 equals to the same technique, dm d less than m, phi of d of x times phi of m of x. Okay, so now this turns as integer coefficient, and this term also monic. And this term is also monic. Okay, so this term has the integer coefficient, this term has the integer coefficient, so we prove that this term has integer coefficient. Because they are all monic, so phi must be monic. Since monic, so it must be integer coefficient. Proof. Done. Okay. Okay, so I think these are 3 basic property that hope you should know. There are more advanced property, but this should be simple. Okay. So I also want to say, yeah, I think this is good results. And the next time that I want to prove that one interesting fact that which basically I will say here. So one can use cyclotomic polynomial to show that there are infinite primes one mod n for any n. Basically this is the same as this is the restricted version of the Dirichlet theorem. So n plus b, if a, b are corresponding to each other, they're infinite prime of this n plus b. This you need to, if you want to prove this, you need to use the analytic number theory and the group character. So this proof is much more difficult. You need to start from a group G and then go to some U1 and play around with the character of the abelian group, and then using the power of a tool to define the Dirichlet series, and then play around with the analytic number theory, which is a heavy machine, which you can prove this is true. But in a very special case, that this one mod n, that one can actually use the cyclotomic field, cyclotomic polynomial will give you something really weird results. Okay, see you guys next videos.